example problem, we have a balloon with a volume of 160 milliliters at a temperature of 50 degrees Celsius. We need to figure out what the new volume will be when the temperature is decreased to 25 degrees Celsius. As I look at what's going on here, I can see that my temperature is decreasing. Because volume and temperature are directly proportional, a decrease in temperature means that I expect the volume of my balloon to get smaller as well. Since the problem didn't mention pressure or number of particles, we just cross out those two columns and assume that those things remain constant. We also know from making our various graphs in class that we can't really work with temperature in degrees Celsius, so before I start, I'm going to add 273.2 to each of my temperatures to convert that temperature into Kelvin. So next I'm going with my information gathered and my chart all filled in, now I need to work on downscaling the volume of the balloon from 160 milliliters to something smaller than that, which will happen as the temperature is decreased. In order to do this, I'm going to multiply my 160 milliliters by a scale factor built out of the 2 Kelvin temperatures and assembled in such a way that the 160 milliliters will in fact be smaller when I'm done. Because I want this conversion factor to make the 160 milliliters get smaller, I'm going to stack up my temperatures with the littler temperature on the top and the bigger temperature on the bottom, so that that represents a scale factor of downscaling by a factor of 298.2 Kelvin over 323.2 Kelvin. When I do the math here, I find out that my new volume of my balloon is 148 milliliters, which is smaller than my balloon, which reflects the decrease in temperature, and so I feel that my answer makes sense and is appropriately scaled according to the direct proportionality between temperature and volume.